Yeah, so now we are going to start with our second data organization, which is linked list. So basically, what is linked list? You basically, if I am not wrong, that many of you might not be very much similar or like used to with the linked list. So it might be a very new thing for you all. So in the very starting, I would not suggest you guys to go deep into the linked list. In the very short, if I can tell you that linked list is nothing but a collection of variable number of data items, right? So this linked list contains of basically of two items. I can say in the very starting. So if I make a linked list like this, and divide this into two halves or two partitions like this. Here we have the first one as the data and the second one as the pointer. So the first part of this stores the data part or where the values will be stored in will be in this part, and this part contains the pointer which contains the address of the next linked list. Yeah. So this part contains the address of the next data element in the linked list. You can say here also that in this linked list, if we remove this head part now for now, if we remove this part, we can see that data one is something data which we don't know right now. We have only for our demo we have allocated this value to the linked list, and 2000 is the data address of this second data element, which is 2000 there, and we have stored this 2000 address uh, into the pointer part of the first data element. Right. So this value is being stored here, right? So this is the basic key concept behind how Linglist works. And if you don't know that what this head is and this null is, so basically null indicates that nothing is there in the last of this array. Sorry, linked list. So this null indicates that the linked list ends here and there is nothing after that. Yeah. So you might be wondering that what is now head. So in the very short, I can tell you that head is nothing, but it is also a pointer, like this pointer that is showing the address of the next linked list. It is a pointer which is pointing towards the first node of the linked list. So it is not conventional, but in the conventional data structures, we use heads to store the address of the first element of the linked list. Yeah. So that's all about, I think, so linked list. When the linked list will come into the your syllabus, I will brief you more about the linked list and I will tell you more about that. So the third data organization is the stack. So let us now quickly read that what it is written over here. So stack is an ordered collection of elements, but it has a special feature that insertion and deletion of elements can be done only from one end, which is known as the top of the stack. It is also called last in first out feature of the stack. We can have two operations in stack, which is push and pop operation. So here we have an example over here. And if I try to tell you, explain that what is stack by this example, I can easily tell you that stack has an indexing from the last up to the first element. If you are not known about this stack, then I tell you the first element will be stored into the bottom of the stack, correct? And if we store one more element, then it won't be stored here. It will be stored above the first element, which is second. Yeah, so if we like push or insert a value of 10, then 10 will be stored here, right, in the first place. Then 20 will be stored here, 30 here, 40 here, and similarly 50 here. I'm really sorry for the this pen. This pen is generating some issues. Really sorry. So yeah, so if I say here, if we push a value of 1 or 2 or anything, then the value, if I push the value into the stack, then it will be automatically stored in the topmost position of the stack. If the stack has a memory of 10 elements, and if I try to push the 11th element into the stack, then it won't be stored because the maximum number of elements has reached of the stack, and this stack is not able to inculcate or to take one more element. So it will reach the position of its fulfillness, and the element would not be able to be added into the stack, and you will get an error message. So this is the concept behind the stack, and we have two operations like push and pop. So I was sharing that if we insert elements, so in technical terms, in stack, we use the word push to push the elements in the stack, and the pop is used to delete the element from the stack. So basically, in stack, if we push the element into the stack from one end, then similarly, we have to also delete the elements from that end only. I'm drawing one stack. We Here we have value 1, here 2, here 3. If For how this stack is created, we have pushed the value 1 as first, value 2 as second, the value 3 as third. And if we are going to push the and if we are going to pop the operation here, if we are going to apply the pop operation here, then the value which is 3 is firstly going to be deleted from the stack. So why this is so? This is so because the stack deletes the top of the value of the stack, and this deletes the topmost element of the stack. Yeah. So now let us. So this is a simple question, I think so. Given some operations are given here, and we have been given four options that what will be the correct option. I think so. Or the answer is also given here. You can just wait or pause the screen from your end, and you can just solve this question, and you can see and analyze that have your that your concepts are clear or not. So moving on, we have the fourth one as Q. So Q is based upon first in, first out element. So basically, if I tell you a real life example, you might have been to various weddings or parties or something, and you see that there are several plates or something, plates or like spoons or the cutleries are kept over there. And if you just take one plate from the like whole bundle, you take the topmost plate, right? And you do not take the plate from the bottom. So similarly in the queue also, if we remove element from the queue, then the element which have been kept first on the queue is removed firstly. So you might be wondering that what I'm saying, and I'm similarly getting confused at what I'm saying. Let me rectify things for you. So yeah, so for a queue, new elements are added from one end and elements are removed from other end. So if I draw a queue like this, yeah, if I am drawing a queue like this, sorry, just a minute. Uh, Yeah. So if I'm drawing a queue like this, then if we try to insert the elements, we can insert from this end. This is the front end, and we can remove the elements from the rear end also. So basically, we maintain two pointers like front and the rear end, and we maintain the insertion and deletion from these pointers. Yeah. So for now, I think so. This information is like enough for you to stick on the points, and in detail we will study this array and a stack and queue in our third unit. where we will cover the whole concept of this stack and queue in very much depth and detail in the third unit. I think so that is in the third or fourth unit, I guess. I'm not very much clear about the syllabus, like unit's name, and it is in the third or fourth unit, I guess. Yeah, so in the fifth, we have tree. So tree you have in detail in your fourth unit, where I have different types of tree like B tree, AVL tree. So do not worry about these things. You will get to know these things very much soon. So in short, if I tell you about the tree, then a tree is a non-linear type of data structure in which data items are arranged in a sorted manner. There is a special data item at the top of the hierarchy, which is called the root of the tree. Yeah, so if I tell you from this graph or the example we have here, the element which is at the top of this structure is the root node, and every like if you treat this A as a parent, then you can see the two lines coming from A, which is coming towards B and C. So A is the parent, and the child of this parent is B and C, which is being denoted by two arrows, which is coming towards B and then towards C. So I can see that the A is the root node and it has two parents as B and C. Similarly, B, if I take it as a parent node, then we have similarly two childs, D and E. And for C, we have parent, for the parent C, we have child as F and G, right? So, whatever we have studied in our previous two sessions have been pictorially presented in this page. You can see data structures as primitive and non-primitive, and primitive have int, floor, and character. Non-primitive has linear and non-linear, array, stack, queue, linked list. Non-linear has trees and graphs. So yeah, that's all for this session, and we will connect tomorrow or day after tomorrow very soon to just start with the algorithm. That what is algorithm and what are different complexities like big O, time complexity, complexity. Yeah. So we will cover these things in the next session soon. And for children, uh, study well. And yeah, that's all for now. Thank you.